In this video, we're going to look at topic 72, example 1, factor a quadratic expression. So we're asked to factor the expression, and we're given two examples here, part A and part B. Part A, we have x squared plus 7x plus 12. So in terms of factoring, what we want to do is something called the factor sum method. So I'm going to use what's called the factor sum method. And what we want is we want factors of our c value. So, right, maybe you remember this is ax squared plus bx plus c. So we want factors of c, which in this case is going to be positive 12. And what we want them to do is we want them to have a sum of 7, positive 7, in this case our b value. I'm actually going to move that over a bit, because I'm going to put my work under there. So we're going to put that over here. So we're looking for factors of 12 that have a sum of 7. What I'd recommend is, usually I just list all of the factors. So things that go into 12 would be like factors of 12 are 1 times 12, 2 times 6, 3 times 4, and that's it. All right, 5 doesn't go into 12, 6 we already have listed. As you get more involved with these problems, you're also going to have to start looking at possible negative values. So you could potentially have like -1, -12, right? Because -1 times -12 is a positive 12. So those are just possibilities. And again, as you get more involved with these problems and you go through practicing them, you'll see and you'll get used to using some negatives. But just keep that in mind, and I'll point that out a little bit more in example B. So the next thing we want to do is we want to add up these factors. So we would do 1 plus 12, and that's a sum of 13. Well, we're looking for a sum of 7, so that doesn't work. 2 plus 6 is a sum of 8. That also does not work. And 3 plus 4 adds up to 7. That works. That's what we're looking for. So these two numbers here, 3 and 4, are going to be our factors. What you can then do is you would take your expression, the trinomial here, the quadratic trinomial, and you're going to break it up where we have two binomials and our factors being positive 3, positive 4. We would just say x plus 3 and x plus 4. And that is a factored version or factored form of our original expression. And there'll be a lot more detail to this. You'll need to keep going through some problems to get the hang of this and to practice this. But the basic idea in its simplest form is you're ultimately looking for factors of c that add up to b. So in this case, factors of 12 that add up to 7. Okay, so let's take a look at problem B. Now the difference in B and A is that in problem B, we have an a value here. Okay, so that's going to throw it's kind of like an extra step, okay, or an extra couple steps. It's not as simple as just taking factors of c and looking for what adds up to b. Because in part A, again, that value of a was a 1, so it really didn't impact anything. This time it's a 2, so we're going to have to be careful with that. So I still have my a, b, and c values. I'll highlight them accordingly. So we have ax squared plus bx plus c. This time we're going to use something called the AC method. So this time we're still going to look at factors and sums, but this time we want the factors of a times c. So we want the factors of 2 times -3, which is -6. All right, so we are looking for factors of -6 that have a sum. The sum stays the same though. We still want a sum of -5. Okay, so that's still the b value. That doesn't change. Okay. Again, the major difference here is that we're no longer just looking for a factor of c. We're looking for AC, a times c. So in this case, -6. So I would list my factors of 6. Again, since there's a negative here, we're going to have a whole series of factors, and what I'll recommend is that you write all of the possible combinations you can, and as you get better and more familiar with this, you'll start to learn kind of some tricks and some shortcuts on what type of factors you should be listing. But for now, I'm going to list them as 1 times negative 6, negative 1 times positive 6, right? Because both of those will get us negative 6, 2 times negative 3, and negative 2 times 3. Right, so those are all my possible factors. All of those would multiply to get negative 6. I'm going to add these up, and I'm looking for a sum of negative 5. So 1 plus negative 6 is negative 5, so that works. Those are the two numbers I'm going to use. Right, so 1, negative 6 will be my factors. If I was to add the other ones up, I would get a positive 5, which doesn't work. You don't need to do this once you find the factors. 2 and negative 3 would be negative 1, and negative 2 and 3 would be positive 1, so none of those work. Now my factors of 2 and negative, not 2 and negative 3, 1 and negative 6, we're going to write those kind of in the middle of your expression. So we're going to make that negative 5x. That's going to turn into a positive 1x minus 6x. All right, and think of it this way. If we were to combine these two terms, we would get back to that negative 5x. So all I'm doing is kind of splitting it up into some numbers that'll be a little bit better for me. So that's the first step of this. There's a lot more going on. So that'll give us the factors. That gives us now an expression with 4 terms. And the next thing you're going to do is factor by grouping. So what I want to do is I'm going to take my first 2 terms and I'm going to factor out whatever they have in common. So in this case, they both have an x, and there's no number that goes into both of them. So I'm going to factor out an x, and I would be left with 2x plus 1. Right, think of that as undoing distribution. If I was to distribute this x back in, I would get back to the original, or the step before where I came from. You do the same thing. Actually, you know what? Let me color code that a little better. So I would take out an x, and I'd be left with 2x plus 1. I'm then going to do the same thing with my third and fourth terms, so these two here. Negative 6x minus 3, I'm going to take out a negative 3, goes into both of those. Again, as you get a little better at this, you'll understand why I picked a negative, but for now, you'll see what happens. And I'm left with 2x, so negative 6x divided by negative 3 would be 2x. Negative 3 divided by negative 3 would be positive 1. When you get to this step here, these two expressions inside the parentheses should match. They should be identical. If they're not, something went wrong along the way. Either you didn't factor out the greatest common factor from the previous step, or you're not using the correct factors, okay, from the factor sum chart. But at this step here, those two expressions should be identical. From here, it's really easy. We're going to take those matching expressions, and we're going to write them once. This again is factoring. It doesn't look like it, but we're actually factoring that 2x plus 1 out. And then we would write the leftover pieces. So this x and this minus 3 would be written as their own group. And then this is our factored form of the original expression. I know it seems like a lot is going on there, and there's really only one example here explaining this. But as these videos go on, I'll explain this process again a couple more times in this lesson. But the idea is you're looking for factors, again, AC method, the first term times the last term, that 2 times negative 3. You're looking for factors of that A times C that add up to your B value, that negative 5. The good thing about this is that the process is pretty much the same thing each time. Obviously, you'll have different numbers with each example, but after you do this enough times, you'll get the hang of it and you'll be pretty proficient at it. But these problems, almost more than any other type of math that we've really been working on, is you only get better at these with practice. You're going to make mistakes, you're going to run into some trouble, but using that factor sum method over and over and over again and just going through the process, eventually it's going to click, and then you'll just know what to do. And you'll be able to kind of do this without, too much thought and too much concern. you'll be able to kind of run through these problems pretty efficiently, right? But that's how you would factor these quadratic expressions. In part A, your A value was just a 1, so it's a little bit more direct. In B, we had an A value of 2, so we had to use what's called the AC method. Actually, let me write that. So we would use the AC method. All right. Go practice them.